Good evening, good morning, or good afternoon, everyone, because you are watching us from different places in the world. But considering that we are based in Poland, let's just assume this is good evening for everyone. Welcome on the second edition, the second sprint of our webinars here at Stanversity. This time, we're doing it a little differently. We're going to have another host soon. So I know you'll be missing me, but most likely you want to have someone else who can also discuss with our awesome experts. We're going to have a little broader scope, not only industrial one, but also more focused about the business principles, about the data science, about the technologies that are regarding the digital transformation. It's going to be here, directly in the webinar and also a podcast. So what I can tell you, a little bit of the update about ourselves. Our studies has just started. We are already after 4 courses. Our awesome hoodies, as you can see, they were shipped to our students, and they are super satisfied with them. And generally, we are taking the highest possible scores of the Net Promoter Score, which is the advocacy score of our studies. We are nailing it with the 86 on 100 scale. So obviously, just to give you a comparison, we're compared to, if you compare ourselves to like Stanford or Harvard courses, which are receive about 26 or 27, we receive 86. Naturally, we're nowhere close yet, but the quality of education that we are providing, the quality of the executive education we are providing here in Poland is absolutely best in class. So, ladies and gentlemen, please welcome my new guest today, Professor Vinicius Brei from both University of Porto Alegre, but also a research associate at Massachusetts Institute of Technology, and he's a world-class expert in data science. So, ladies and gentlemen, welcome Vinicius Brei. Hi, Vinicius. How are you doing?
Thank you. Hi, Maciej. Thank you. Thank you for the introduction. Thanks, everyone who is watching. It's a pleasure to be here.
Amazing. I'm super happy that we eventually managed to find time to have you in our webinar. This is super. I'm super happy that we are kicking the second round of our webinars. As I've told before, we're expanding the scope. We are not only focused on the industry topics anymore. We are also focusing on other digital technology and educational aspects. So I hope our students will, and our listeners and audience will receive even more value. So Vinicius, could you maybe introduce yourself to our broader audience in a few words?
Yeah, sure. My pleasure. So I'm an associate professor of marketing at the Federal University of Rio Grande do Sul in Brazil. It's one of the top business schools in the country. I also have been a research fellow associate at the Massachusetts Institute of Technology, MIT, since 2019. And previously, I have been a visiting scholar at Harvard University, where I concentrated on research on social psychology and more specifically on machine learning. How can we work with machine learning to tackle business problems and to understand consumer behavior and to feed business analytics decisions? And previously, I'm a PhD from HEC Paris in Paris, and I have a PhD in Sciences de Gestion, Science of Management, and in marketing too. So this is basically my background in terms of participation in universities. In my currently, I'm currently chair Tramontina Elektrik here in my university. And I'm very excited to be part of this effort that I'm very keen to help, and hopefully you enjoy both the data science and the machine learning course that I will teach.
Yeah, I'm pretty sure that our students will love it. So, Vinicius, if I understand correctly, and let me just paraphrase it, like I understand you're on the frontier of marketing, psychology, consumer behavior, also industry, all this connected within the broad concept which we call the data science.
Right.
Wow.
Yeah. I work my field of research is I work in close collaboration with the industry. As I've said, my chair here is sponsored by a major Brazilian group, a 100-year-old group. It's called Tramontina. They export to 120 countries. It's a pretty big company. So we work in close relationship, and my major research interests are market potential estimation and demand prediction. So I work with different types of B2C and B2B research problems, trying to model consumer behavior, try to estimate demand, try to predict demand, which at the end informs production. So we need to be aware about how the demand of the consumer demand, either B2C or B2B, informs or how is it used by the industry, by the company to produce adequately to its consumers or to its markets. So my goal is to combine the data science knowledge to inform these decisions. And this is how I try to do data science. I try to combine math and statistics with computer science knowledge, but most importantly, with business problems, how to use math, statistics, and computer science to solve real problems of companies.
Sure thing, sure thing. So, okay, so very straightforward question for you. So considering business and data aspects, what is the biggest challenge of businesses right now?
Well, there are quite a few challenges. First of all, companies are flooded with data nowadays. The data is not a problem. How to work with data wisely, how to take good decisions about what to do, where to invest, which are the most challenging and important problems to prioritize. This I would rank, these are the major problems. Also, considering what we've been doing mostly here in collaboration with MIT, with Harvard, and in my research group, there is a lot of many different types of research problems. They cannot be solved with proprietary data. We need publicly available data. For example, when you are estimating a market potential of one specific industry, sometimes you have no information at all about your competitors, but you can use spatial data science using publicly available data, such as satellite imagery, census data, survey data that is widely available everywhere in most countries. Mm-hmm. We can combine this type of data with World Bank data and this type IMF data and so on. So data is not a problem, but how to choose and how to use it wisely is something that is very, very challenging, time-consuming, and can be very expensive if you don't make right decisions in terms of where to invest your time and resources.
Okay, but so like few things like just struck me. So one thing is like the way like you have taught to look and to structure the problems properly, right? To structure.
Right. This is the first step always.
So how do you approach it? Like please, professor, teach us how to do because I remember from my McKinsey times, I spent years there.
Yeah.
Like problem solving, quote unquote, right? This is like one of the most important skills you need to have. If you look at the competences 2050, right. what won't be changed, problem solving skills.
Right.
So let's stop here for a moment, because you have mentioned a lot of interesting things, but all of them are so valuable, but I want to stop here and discuss. So how do you tackle the problem solving issues within the data science and generally like the data projects?
Sure. This is where we spend quite a good amount of time to adequately frame the problem. Usually when we start talking with people in the industry, they have big problems and they don't know exactly how to frame it. It doesn't matter if it's in the industry, in academia, it's pretty much the same. When a student comes to us in a PhD level, for example, he or she usually is thinking about how to solve the world problem, something that is very, very important, like how to treat COVID. Of course, no one individually can solve such a huge problem. So the first challenge is how to frame it in a solvable way. How can you do that And how can you frame this problem in a way that you have the right tools and the right data to answer this question? Sometimes you need to frame the question and split one big question in two or more smaller problems that are solvable, and then you can rank them and say, okay, this will be my top priority, and then this will be the second and the third. So usually one of the most important things when we think about data science is how to frame adequately the problem, how to specify which ones are the most important, and how to rank them in terms of importance. This is the first step always.
But do you have a special method for that, or this is just discussion and workshops?
We do have we do have some methods to do that. Usually, it starts with the feeling when we now I'm talking not about academia, but I'm talking about industry.
Purely.
So when we are talking about specialists, they have problems in their minds, and they know which ones are the most important. So usually, I start with a conversation, and sometimes we do specialist panels. We can do Delphi. We can do we can apply different types of methods, and trying to filter what is really relevant, what is not essential. So there are different ways of dealing with these problems, and hopefully I will dive into these methods to discuss problems in the first session of our data science course.
Okay. But you say that you're disaggregating the problems into smaller pieces, so kind of like the statement would be avoid word hunger problems, right? Rather focus on the smaller part. So, but how do you make a bigger bigger transformation picture of these small projects? Because from my experience, the problem is that, okay, I'm tackling only this problem and I'm kind of limiting myself. Like, am I not limiting myself to only this problem? Or how do you frame it within bigger type of problem solving structure? Okay, so I'm solving this small chunk, but at the end of the day, I need to kind of make a bigger map of it. How do you approach it?
I try to develop a roadmap.
Okay.
I always try to develop a roadmap. So a roadmap, this is the first step, and this first step we are going to have this and that output that will feed the second step, and so on. So this is how I try to do it. So I try to develop a roadmap with concrete schedule for each step, which are the expected inputs and outputs of each step, and how they will be connected. This is a very simple way, and I would say straightforward way of having something clear that you can put in your wall or in your wallpaper or somewhere that you find that you can go often and check and see, okay, and am I doing it right? Have I thought correctly about the roadmap? Are the inputs and outputs and what's going inside each step, is it correct? It's a simple method that I use, but it usually works pretty well because it's simple and straightforward and very, I would say, objective too.
Okay. So kind of to put all these things into the bigger picture of the roadmap and the strategy.
Right. So you have the big picture all at once, and at the same time you have the smaller pieces, and you know what are the inputs, outputs, and how they are connected, and you know what's going on next, what will happen next.
Okay, but does it be, and this is also linked to the direct impact on the company's performance metrics or KPIs, P&L, etc.
We always try to combine business knowledge, business theory in terms of strategic planning, and we have a lot of tools for that. So and this is something that you don't need very fancy tools for that. You can use old style strategic planning methods to do that, like SWOT analysis, and you can do it basically. So you can combine traditional tools that we have in the business world,
like MBA
business literature, MBA like tools, exactly. So things that are quite easy to apply, they are very traditional and very solid in terms of application. So we can combine this with recent knowledge that is coming from the data science world. Something fancy things that are in the data science world quite new, like quantum computing and things like that, like cloud computing. The ideal world for me is to combine traditional tools that work well, that are proven to work well in the business world, with new tools that we are having that have been developed in the last 5 or 10 years maximum, some of them just in the last 2 or 3 years from the data science world.
Mm-hmm. Okay, can you maybe talk a little bit about the case study, where you have actually, for instance, use the very easy business tools
Right.
like SWOT or
Cool.
whatever,
Yeah,
like
sure.
balance
Right.
scorecard or whatever, but
Mhm.
connected it with the quantum computing, for instance. By the way, we can talk about quantum computing a little bit because I have no idea what is this, and I really want to know. But like talk a little bit about how you did this. Like situation, task,
Sure.
approach, result type of approach.
Yeah, sure. I can talk about one of the projects that we've been doing with the industry. So, for example, I work closely with the electrical materials industry in
Okay.
Brazil. So, light switches, lamps, lightning problem, for example. So, we have different projects. There is a big problem in this industry is that in opposite as the car industry, where all the competitors know exactly how many cars have been produced by each manufacturer. So in the car industry, say Audi know exactly how many BMWs were produced because you cannot hide a car, right? So it's quite everyone knows exactly how many units are being produced by the other player. But this is not what happens, for example, in the electrical material industry, because the size of the product is much smaller. You have many SKUs in one type of light switch, for example. You can combine different products. So it's not as a car. So you don't know exactly how is the market share, who is growing, who is not growing, what makes people buy this type of product is a quite hard product to do research about. So it's very challenging to predict demand for this type of product besides time series estimation, which is something that sometimes fails. Time series is always based on the past. So if you have a new technology, you cannot say that the future will be as the past was. So you need to have more fancy tools to do this kind of research. So, for example, in this industry, we are combining different type of publicly available data to try to estimate energy consumption and try to predict the purchase of electrical materials. So, for example, I'm using satellite imagery. So we have satellites that lots of images that are available nowadays for free, satellites. And I don't know if those who are watching us now, if they know about it, but satellites 20 years ago, they were the size of a car. Nowadays, they are the size of a shoebox. So, and the image is very granular nowadays. You can have a 30 centimeters of resolution. So we can detect cars in parking lots very easily. We can almost read a car plate from space, and we can measure parking lots occupancy and try to predict sales performance of stores based on parking lots occupancy. So we are combining, for example, satellite imagery with census data, trying to predict area attractiveness, try to predict where people are flowing from where to where. So this is spatial data science. It's not only
How
data
do you
science,
get?
but
No, I need to stop. How do you get the data? How do you get this data?
well, there are different sources of satellite imagery that are free. Actually, you can, for example, the VIIRS satellite from the US government is absolutely free and it has a resolution of 700 meters. But you also can have Google Maps data, Google Earth data. You can have with 1 meter resolution. If you want to do a really military application, so for in the ballpark of 30 centimeters, then you would have to pay. But you can do a lot of things with the freely available data that you have.
Okay, so let's go to this light bulbs and this electronics. So you were trying to estimate the energy consumption
Right.
in which country?
Well, we are doing it in Brazil initially right now. So we are. This is very interesting because the usual way you measure electricity consumption is by old equipment that each household or each business has. We don't need that. You can measure energy consumption that has a very high correlation with luminosity. You can measure it from the space at scale. So you can measure by using satellite imagery at scale. And more importantly, you not only can measure it at scale very rapidly, even daily. Of course, sometimes if you have clouds and there are some limitations to the way you're going to use it in terms of how frequent do you need this data, right? So this is something that, of course, you need to be aware of. But you can use different perspectives in terms of zoom. You can zoom in smaller areas, larger areas. You can predict market energy consumption in different areas. Sometimes the geographical borders can be the traditional ones like city, neighborhoods, states. Sometimes it's a mix of them. You are not limited by borders. You are limited by the quality of image from the space. So it's something very interesting. And in this case, we combine data science because we use machine learning, we use statistics, we use business knowledge to know how much we can use this type of data to infer or to predict demand.
Okay, so from these lights seeing from the sky,
right,
you came back to how many light bulbs we need to actually produce.
Right. So if we take ground truth and we have an estimation from the industry, there are some business associations that have estimations and they do surveys asking each manufacturer, how much do you produce? But of course, a manufacturer in a survey, he or she, he can lie. He can say, well, we have produced much more or much less. But you cannot lie to the satellite because the luminosity is there. You cannot lie. It's a measure of pixels, pixel intensity. So it's something that it's not limited by if your competitor is telling the truth or not in a survey.
Okay, but you have this input, which is like, let's say, light volume. Let's call it this way, right? So,
right.
But how
luminosity,
do you link it to the luminosity? So how do you actually link it to the units of light bulbs?
Cool. Historically, we have, this is interesting, very good question. So when we use data science, we usually try to combine different types of different data source, different types of data. So in this case, in this specific research that I'm talking about, that we are talking about right now, we are combining historical time series data, production data, for example, industry data, something that we already know. It's not something that people are asking right now. It's something from the past. And we have the time series from the past, and we have all the correlation between luminosity and sales from the past, and we can infer with a margin of error how much will be the consumption in the future. In a very interesting way, because we are not limited in the future by the type of data that we had in the past. Because on the past, sometimes you have only monthly data. But if we have a good time series and we can calculate precisely the correlations between the satellite imagery, the luminosity, and the past sales, we can have predictions from the future in different levels of geographical areas and different levels of time frames. We can expand for not only monthly data, but we can do weekly data, weekly sales data, and sometimes even daily. We can do this kind of effort too. Of course, the more granular you do, the more you predict, the more error usually you have. And this is where we spend more time working on how to reduce the error when we go more granular. So this is a very challenging problem.
Okay, so you're using historical production and luminosity, and then based on that, and what is the kind of time span between luminosity and the actual? Because I'm understanding one factor is before the other, right? It happens before we actually need these light bulbs, or which one is faster, like egg versus chicken? Like egg versus hen?
That's a very good question too. So this is there is a lag, right? There is a lag between what we are usually just to give you a one number that summarizes this relationship. The correlation is 0.69 usually about luminosity and sales. It's a quite strong correlation, 0.69. It's quite strong. It's quite strong. For social science problems, it's a quite strong correlation. If we consider that correlation goes from -1 to +1, so 0.69 is quite strong. So what we do usually, this is another challenge that we have right now, because most of the time when we work with the industry, we don't have the B2C data. We have only the B2B, which is something challenging. For example, IKEA can order from the manufacturer a light bulb or a light switch, and sometimes an IKEA may buy it in a buying center. Sometimes each store might do the order individually. So it's quite challenging to know how to estimate. Am I going to estimate the demand of the buying center, IKEA's buying center, or should I estimate the demand of each IKEA store individually? And more importantly, not only the B2B prediction we work with, but we work especially with the B2C. From the IKEA order to the manufacturer, how much time does it take for IKEA to buy it and then to sell it for the final customer? One very, very challenging problem that most industries have nowadays is, how can you estimate final consumer demand when you don't have the data from your retailers, for example? And this is the kind of problem that we try to solve with publicly available data. So we have the B2B orders, but we don't have the B2C sales.
So let's assume that I'm a PG or like Unilever. So I'm a company that produces goods through like Gillette goods or whatever, right? I produce like toothpaste, but I sell it from Amazon. I don't have a D2C channel. I don't have my own direct to customer channel. I don't have it, right? I'm selling through Walmarts of the world, through Targets, through Amazon, right? So how would, and on the, let's assume that we are discussing only the offline channel. So how can we use the public data to estimate the demand on the toothpaste?
Good. So it's what we do is we create what we call gravitational models. So for example, gravitational models is when you estimate the optimal distance between each store and your customer is. For different types of products, people are willing to move to buy. For example, if we talk about specialty goods like luxurious cars, usually people will maybe drive 50 kilometers. Should I say kilometers or miles?
We're in Europe, so kilometers.
Good. Okay, so it's a world. Yeah, so it's pretty much the same for me. So for different types of products, you will be willing to drive a long way to have this type of product. But depending on the product, if we're talking about toothpaste, you're not going to do that. You're not going to take a bus, take a subway, or drive 20 kilometers. So you need to have a smaller distance between each point of sale to the customer. So this is what we call gravitational models. So it's a spatial data science type of problem that we solve, estimating the optimal distance between each point of sale and where the customers are. So we use publicly available data like census data. We need to calculate how many people are in each census block, what are their income, educational level. And something that we are working on, especially at MIT, is with mobility data. So there are different types of mobility data, especially after COVID. This was a very important, different data type. Different companies work with that, like SafeGraph, Cubic. So they have measures of movement from people. And everything respecting privacy. We don't have access to individual data. It's analyzed in a aggregated way, but we know what's the average movement from people from one specific census block to the other, and then we can calculate these gravitational models to estimate what is the optimal distance from where the product is and the customer is.
Okay, so this all sounds super, like NASA level type of
No,
project.
not at all. Not at all.
No, I know, but this sounds, for an average business person, it's like, spatial analytics is like, mind blown type of thing. And by the way, there is a very cool startup from Poland called PlaceMe. They are actually doing the spatial analytics, like retailer data and all this type modeling.
Cool.
This is super interesting. But like this is all but right now you're talking about a scientific research, or this actually had a real business application?
This is very practical. Very practical.
Okay.
We have had this kind of spatial data science problems since the 1960s. So the first gravitational models that have been created in academia to support the industry, they have been created since the 1960s. So what is different nowadays is that we are using more machine learning, so more recent developed methods like deep learning, some different types of more recent methods to handle or to solve fastly and wisely old problems. But this is very, very applicable. If you want to open a new business, where should I open the new business? A new brick and mortar store? Where? So this is a very old problem, right? It has been always there. This is the most. It can't be more. This is the kind of problem that every company that is working the real world, not the digital world, has. So this kind of model that I'm talking about, they help to solve this question: where to open a new business? What size should be my store? How many customers should I be able to serve on this specific store? So for me, data science is only useful if we can translate into solving real problems. Otherwise, what's the purpose, right? We should do something different.
Do you think we can use the geospatial data? I guess that this is like a natural case, and this is super popular, like solar energy and solar panels. It's a super huge thing in Poland right now. Everyone is installing it pretty much everywhere.
Right.
And I'm just wondering how we could approach this exercise of estimating the market saturation of solar panels in Poland, to kind of, try to see if, because there are more and more people, more and more companies entering this market. And I'm wondering where we can see this, point in which, the curve goes down and you can't actually, So I'm just wondering if we could actually use this, because this is for me.
I guess so. There are different, very recent research that is using the same type of data that I described in the beginning of our conversation, satellite imagery. So you can actually measure from the sky. You can see houses, and you can measure houses with that already have, for example, solar panel roofs, and you can measure buildings that already have solar panel installed. And then this is one possibility. So you can measure quantitatively where there is already a market potential to install new solar panels, where there is already a lot of competition established. So this is just one idea, right? Something that you can do using almost always freely available data. You don't need to do fancy, expensive surveys that you're gonna need to ask people in each household. Are you willing to do that? Are you willing not to buy it? So this is, sometimes it works, sometimes it doesn't. So usually I try not to count too much on what we call primary data, that is survey, because it's sometimes when you ask people, would you willing to buy? People say yes. Are you going to buy? Yes, but it's what people say is not usually what they do. So I prefer to work with ground truth data, in the sense that measure what already happened, actual behavior, not intention. Actual behavior is more. I trust more on actual behavior than intentions that we usually gather by surveys.
Yeah, but this is the case we also have in pricing research. Like there's a certain way of asking questions not with regard of like would you buy it, but rather to show the type of a product, the try, but read between the lines, to estimate the willingness to pay, things like that. This is slightly different, but again, this is like act on behavior, not on intention.
And again, I'm not saying that these other types of research that are useless. Not at all. I'm a marketing faculty. I know these kind of methods. I work with them. I still use them, and they are interesting and important depending on the type of problem that you are dealing with. What we are talking now is a more, I would say, greater problem in terms of scale and complexity. So when I'm talking about data science, we can use both for smaller problems and to bigger problems. So these examples that we have discussed until now, they are mostly big problems, like how can I estimate the market demand? How can I estimate the market potential? Where to locate stores? How to calculate optimal distance between stores? Things like that. They are quite complex, I would say. Sure. And I'm not saying that running surveys or doing experimental research, they should not be done. On the contrary, they are very important for different stages of business development. When you are developing a new product, nothing better than a qualitative work, nothing better than you can do. It's very, very important to do experimental research, trying to do prototyping and things like that. So.
Yeah. Okay, so Vinicius, like kind of, but we are like super focused on spatial analytics, right? And this is something that naturally emerged in this discussion, and I'm understanding this is. So these are the practical problems that you were actually solving for companies, and they were actually applying it. Do you know do you know kind of like the impact that was created within this project?
Yeah, this is interesting. It's a good question. So most of the company executives, they are very knowledgeable about sales teams, how to work with sales teams, salespeople. They are very experienced with business performance, what works with like salespeople's promotions, things that have worked on the past, and that things that they have learned by a lot, maybe sometimes it takes a long time to get this experience, but they know by heart what to do, but they don't know how to explain. They don't have a concrete method or something that can be replicable in other situations. This is how science can help the industry, because science is always preoccupied about finding things that can be explained, the why of things. Why does it work? Why it doesn't? And many people who I work with, they are really, really smart people, very good executives, but they don't know how to explain why something works and why it doesn't. It simply does, in their opinion. So they have the feeling, but the feeling, it goes, if that specific person retires, so the feeling goes with him or her. And we need to have concrete measurements about things that are not dependent of one person's experience. And in this case, the data science helps us a lot, because we have methods that are replicable, that are created in open source software with freely available data, using methods that are being developed by the best universities in the world. And they are usually available for free. Sometimes the codes are available at GitHub. Usually we publish these results, and we publish also the GitHub repository, where people can go there, download, and try to do the same. So this is how I think data science can help a lot the world in general, because most of the solutions that we are developing in academia, they are not limited to specific industries or to specific problems. They are freely available in open source tools with open source data, with freely available data, I would say.
Okay, so this whole knowledge is just there to grasp it, then, basically.
Right. So I'm not saying that it's easy. nowadays, for example, in my machine learning course, I will teach about automated machine learning. Automated machine learning is it's a recent tool that has been used for when you don't have a lot of time to test different algorithms. Then you do all at once, and you compare it in a tool that you can do all at once. So you can do automated machine learning without a strong knowledge about machine learning, but you will not know how to read the results, how to interpret them. It's good to have a background to know how to use an automated machine learning tool. So the challenge here is to know how deep should I dive into in order to understand these new tools that are available for data science and machine learning. And this is the kind of subject that I will try to discuss in our course.
Mm-hmm. Okay, so we know the data is kind of available there. We know the knowledge is very often open source and we can use publicly available data, but as you said, it's not easy. It's not necessarily easy for companies to do it, right? So imagine an average manufacturing company, like a manufacturing facility. As a manufacturing facility like owner or director, kind of what should be my next steps after hearing this webinar or attending your course when it comes to the data science?
Well, let's say that going back to our starting point, when we think about data science, we have the combination of three major subjects: statistics, computer science, and business knowledge. Statistics, computer science, and business knowledge, right? Usually the owner or people who will be attending the course, I believe that they have business knowledge. They know about their business, they have experience. So they shouldn't be very concerned about training people on that level because they have probably good people to support them. So the other two problems is statistics and computer science. I will try to show what are the paths that people should follow to learn the basics of computer science, especially open source tools like Python, for example, is a possibility, or automated machine learning tools like H2O, for example, is a freely available package. I'm not going to dive into the very hands-on applications because I think this kind of course is more, people are more willing to know the strategic aspects of data science and the strategic aspects of machine learning. So I'll try to keep the discussion around the more strategic way of doing that. Although if the students are interested, I'll be very happy to dive into the details, the smaller details. So going back to your question, you have to need someone that has a basic knowledge about computer science. Not very fancy. Nowadays, a lot of people know the basics of programming, and you don't need to be an excellent programmer to use data science, because most of the tools are already available in packages. You simply download a package to do some kind of analysis, and you apply that package with the data. To apply that package, you need some knowledge about the statistics. And again, you don't need to be a statistician, a PhD in statistics to do that. I will try to show the basic statistics on the course that you need to know. And most of this knowledge, you have freely available data, for example, in Khan Academy, EDX, or other platforms. So I will try to show what are the basics that you need to know in order to adequately data science and machine learning, and where where can you get this knowledge to dive into. So to sum up the question, to sum up the answer to your question, statistics, computer science, and business knowledge. These are the three pillars that you need to do to apply data science or machine learning to your business.
So you're kind of like more focused on reskilling people towards this area, or rather, or finding the people in the capabilities which you don't have?
Yeah, and more importantly, I'm trying to demystify the idea that you need to be a PhD in computer science or PhD in probability, or you don't need to do that to work with data science.
Mm-hmm.
There are lots of open source tools. There are a lot of publicly available data that you can use nowadays, and you can practice, and you can have basic knowledge that that would be enough for you to start with data science. So of course, depending on how far you want to do it, and depending on what resource do you have in your company. Sometimes small companies, they don't have a lot of people to do this kind of predictions, right? So you need to have you need some cheaper and faster solution. So it depends on how complex is your problem. But I will try to discuss the most important, the recent innovations that we have in the data science world, and how can we apply it in the industry, especially considering these three aspects that I've mentioned: the business knowledge, the computer science, and the statistics knowledge.
Sure thing. So you don't need to be a PhD major and PhD professor from MIT to start with the data science, but probably having one on board is not something you would regret in the end.
Yeah, I mean, there's some statistics background that is very important. Otherwise, you won't be able to even to start reading a result and to understand where should you take decisions. So some basic knowledge is mandatory, is important, because otherwise it's very hard to understand the data analysis results. But again, it's not for PhDs in statistics. It's not only for PhDs in statistics. And this is the kind of discussion that I will try to do on the course. I will try to show how deep your knowledge should be, and how can you get this knowledge for free using freely available resource. Hopefully, we are in a very interesting moment of, I would say, in the world in terms of learning. This is the kind of thing that we are doing. The thing we are doing right now, this diversity idea, the course that are available online at this point, there are lots of interesting resources that people can and should use wisely. We can do a lot of things. I would say sometimes even for free.
Mm-hmm. Mm-hmm. So there's a lot of knowledge which we need to which we just need to use. So Vinicius, like kind of maybe like we still have about like a few minutes left before we have like some Q&As, and maybe there will be some. Mm-hmm. But what strikes me and what I'm actually always struggling with is, so what is the newest trend in the data science technology? You've mentioned the quantum computing, right?
Right.
What it actually is.
Well, if we consider the evolution of data science, the reason that why data science is so important right now, because of a combination of three aspects. First, hardware. We have nowadays I don't know if you guys if you have seen that Jeff Bezos this morning, yeah, he went to the space again. So last week. So if we consider the space exploration in the 60s, the computer power was something that it fits here. So it's in a small is for nowadays. So for example, nowadays we have what we call federated learning, which is you can do processing distributedly in using, for example, smartphones from people everywhere in the world. It's not. I'm not talking about AWS, Amazon Web Services. I'm not talking about something professional. You can do federated learning, which is a very trendy new way of doing processing distributedly. So we have very interesting hardware solutions nowadays, including federated learning, quantum computing, cloud computing, things like that. Second aspect, we have data that in a way that the humankind have never had so much data available. We are producing data every day, lots and lots of data. So and most of the solutions that we have for data science and machine learning, they require a lot of data. So deep learning models, for example, deep learning algorithms that are usually the state of the art that we have, reinforcement learning algorithms for robots, they require a lot of data. And we do have a lot of data nowadays. And third, algorithms. So we have new algorithms, and I'm talking about deep learning. Deep learning is neural network. Neural networks, they have been for decades already, but the types of neural networks that have been doing recently for language models, for example, we have different types of language models that are extremely powerful in terms of creating text, songs, videos, things without human intervention. Things that are very, for example, the GPT-3, it's a new algorithm that has been created recently. It was trained with all Wikipedia data. So it can reproduce, create texts that a human being cannot identify if it was created by a person or a machine. So we have new algorithms that are very powerful nowadays. So combining algorithms, data availability, and hardware, this combination explains the power of data science nowadays.
Okay, but still doesn't it still doesn't answer kind of like what is the cloud computing, if we like this on steroids or what is it?
Oh yeah, you mean the relevance of cloud computing?
I mean quantum computing, right?
Quantum computing. Yeah, no, I'm not a specialist at quantum computing, but if we need to summarize the problem is how to make more faster and cheaper processing power, right? So this is because the Moore's law is changing, and Moore's law was developed based in one specific technology. Quantum computing is something that it's not for the common consumer. It's not available. It's something that only the big companies have nowadays, like IBM is developing the first ones. It's something that is still in development, and is a combination of academic physics knowledge with business application, is on the frontier of these two worlds, like academia and business. But this is the kind of thing that will probably boost again or continue or make the data science importance to keep steady in terms of growth, because we usually in the past we have been limited by computing power. This was something that in certain moments of the history, when we see the history of data science, we had problems about lack of hardware, good hardware. So not necessarily data, but also data and algorithms too. But computer power has been a problem, and it is a problem. So nowadays, the solution in terms of hardware is to create either new hardware in terms of, for example, using quantum physics or quantum computing, or using the traditional transistor technology, doing it distributedly. So you can distribute and have more power instead of doing or buying, investing in big machines, desktops or servers, mainframes. Yeah, you do it distributed. Yeah.
So basically, quantum computing is about breaking the Moore's law, the one that we know right now, and or actually sustain it.
We don't know if there will be any other Moore or someone else's name to name what.
But to double the power every.
Moore's law is not as it was. So the law, it seems to, if we see the graphs of evolution, they are not doubling every 18 or 12 or 24 months. It's not changing the way it used to change a couple of years ago. So now we don't have a new, at least as far as I know, we don't have a new Moore law to explain what's going on now. But it seems that we are reaching a threshold that we will need a new innovation in terms of hardware to continue growing with.
So we will have,
I would say in a more sustainable way, because these data lakes they are very energy hunger facilities, right? And this is a problem because there is a kind of carbon path involved with the Google world. It's not for free. When you run a big machine learning model, it's spending a lot of energy. And of course, energy, sometimes it's not renewable. And
so, like the blockchain mining consumes more energy than Argentina a year.
Right. Yeah.
It's crazy, right?
Right. And exactly.
Yeah. But I'm actually super glad that you have mentioned it. So look at this, like how all this is just, I'm kind of look to parting words and just to conclude, because we're slowly running out of our time. But look how all these things become, considering the new business leaders, the ones that we'll be calling the digital champions, considering the industry 4.0 also, is like how all these things are interconnected. Like,
right.
This is not renewable energy, these servers, the machines, this everything, right? It's this model can't sustain anymore, and we're looking for a new productivity paradigm, and hopefully the industry 4.0 or industry 5.0 or whatever we name it will be an answer. So this is actually
and this is the kind of solution that we can do we can contribute to the evolution of sustainable initiatives using data science, because we can use better algorithms. We can use different strategies to develop the current algorithms to do more, to use less energy. For example, we have the technology of transfer learning that I will talk on the course. It's something that when you are starting a new algorithm, don't start from scratch. Try to use something that has already worked in a similar scenario, and then you move on from there. You don't need to start everything from scratch. So this is the kind of thing that will definitely help to save energy and to do more sustainable solutions.
Mm-hmm. But this is actually super important, considering the way how we can outline this course in the future, right? That we need to have this, like, sustainability and environmental aspects also covered.
Oh, definitely.
Because this, while it may not be the case for operational or plant manager or production manager right now, this person will definitely receive the command, the task, the goal to reduce the carbon footprint within some time. So understanding what needs to happen is especially in Europe, right? Especially in Europe,
right.
When we, but also in US, like where Joe Biden wants to effectively limit the carbon footprint. So
this is a worldwide problem. It will be sooner or later, everywhere. Everyone will be concerned about that in the world.
Yeah, but this is actually, but I didn't know, honestly. So thank you for that. That this is all about, but this is not only answering the computing question, but this is also answering far broader, because this servers, this, hectares of servers, they are actually, consuming so much energy.
Very energy consuming facilities. Yeah.
So this is like this case of Tesla, right? Whether Tesla can drive, is how clean the Tesla energy actually is.
Right, exactly. Yeah, it seems very.
It doesn't matter if it was produced by the coal mine, right? It's like you
have lithium and stuff, so it's not that clean, right?
So this is actually interesting. Anyway, Vinicius, thank you for this super awesome 1 hour of talk. Like I think that we could have another 2 of these. So
my pleasure.
Definitely great to hear from you. I see we don't have any questions from the audience. I think they were so overwhelmed with the knowledge, but I'm actually super excited about the course, about the case studies, especially the spatial demand and the light bulbs case. I think this is going to blow our students' minds, similarly in a way that it did with mine. So thank you for that.
It was a pleasure. Very, very, very nice conversation, and hopefully I'm keen to show some case studies of these examples that I've mentioned during the courses. I'll be happy to do that.
Definitely. Anyway, thank you for finding the time.
Thanks a lot. Great to
take care.
See you
on our course.
See you. Bye-bye.
Bye.